Hey everyone, so let's solve today's LeetCode POTD, delete columns to make sorted part 2. So the problem states that we are given an array of n strings strs which are all of the same length. Now we can choose any deletion indices and we delete all the characters in those indices for each string. Okay, so for example, if we have the strs as a, b, c, d, e, f and u, v, w, x, y, z, then if we choose to delete the index 2, then this a and u will be deleted. Okay, similarly, if we delete index 2 and index 3, then after deletion, the final array will be the index 1, index 4 and index 5, means b, e, and f and v, y and z. Okay, so we have the choice of means either deleting a particular all the characters of a particular index or not deleting it. Okay, now suppose we choose a set of deletion indices answer such that after we have performed the deletion, the final the strings words that we will be getting, these words should be in sorted in lexicographical order. Okay, means this should be present in the form of a dictionary only. Okay, now we need to means choose this deletion indices answer array in such a way that this has the minimum size. Okay, and hence we need to return the minimum possible size of this answer dot length. So for example, the question is asking us to simply we have given an array of n strings, each of length m. Now we need to find the minimum number of columns to delete such that the remaining rows that we have are lexicographically sorted. That means this condition is satisfied for all the rows. Okay, after we have performed the deletion. So let's see given input. So we are given the strings as C A, B B, A C. So we see like this first row, first column is not lexicographically sorted. Means the characters are C is greater than B. So this breaks the sorted order. So we can simply choose to delete this particular column. Okay. Now the remaining column remains as A, B, C. So we see this column, the words are given in sorted order. So after we have deleted this particular index, the words will be simply A, B and C. And we see like these words are sorted in lexicographical order. Okay, so hence this will be like the optimal way of deleting only a single indices here, and hence the output here is 1. That means we'll be deleting only one in column here. Okay, so maybe let's see another input. So we are given the input as xc, yb, za. Now we see like this x, y, z is already sorted. So since it is already in strictly increasing order, then that means whatever values are present after that, they will not like disrupt this sorted order. Okay, so hence we'll keep all the remaining indices as well. So in this case, what will be the number of indices that we'll remove? It will simply be 0. Okay, we'll not be removing any indices in this case. Okay, now let's see another input. So we are given the input as z, y, x, w, v, u and t, s, r. Now we see like this z is greater than w, so we certainly cannot keep this as the first column, means the first character. Okay, so we will simply remove this in the column. Now we have y, v, s. Again we have removed this, but again we have y greater than v. So again we cannot keep this column as part of the first column. So we'll simply remove this as well. And again we see like we have x, x, u, r. So again this x is greater than u. So we can also not keep this because none of them will be making the words to appear in lexicographical order. So in this case, we'll need to delete all the 3 columns, and hence the output here is simply 3. So what do we want? We want to find find a sequence of column indices such that that column means denotes the number of columns that we'll be keeping, and we need to maximize the length of that particular subsequence, right? That is what we need to do. So here, for example, if we have if we want to try it in a brute force manner, so what we can do, we have 2 to the power m subsequences possible for columns. If we have m columns, so we have 2 to the power m subsequences, means each column has a choice of either getting picked up or not getting picked up. So what we can do is we can iterate through all possibilities of this power set. Okay, and then what we can do is we can find out whether means we'll create a new string based on the set bits of this, and then we'll see like whether the string that we have created is lexicographically sorted or not. And if they are, then the number of deletion counts will be the number of unset bits. Okay, so in this way we can like iterate through all possible subsequences of the order of 2 to the power m, and then check constructing the means the entire strings in the order of n into m, and then see whether the condition is satisfied or not. So what is the approach? We like the power set will be to generate all possible subsequences of column indices 0 till m minus 1. So there are 2 to the power m such subsequences. So now for each of these subsequence, we will construct the new strings and check like the remaining rows are in the sorted order or not. And we'll generate this for all the subsequences. And now the length will be for current will be set bits. So the number of bits that we'll be deleting is the unset bits. Okay, so it is simply this m minus the length of longest subsequence. And longest subsequence is the number of set bits. So as you can see, like creating this means iterating through all the subsequences will be of the order of 2 to the power m, and then we'll be constructing these strings, or based on we'll be construct the new strings and then see. So construction will take n into m. So and let's see the constraints here. So we see that n can go up to 1000 and n can go up to 100, m can go up to 100 as well. Since this will be of the order of 2 to the power 100 into 1e4. So obviously this will not be feasible here because this will be giving TLE. Okay, so hence we need to think of some optimization to like solve it optimally, because this was the most naive way of solving it. So what can be like the first intuition that we get? Maybe since means the first column can be a deciding factor, because if the first column is already in strictly increasing order, suppose this is the first column, then it doesn't matter what characters are present in the next columns, right? The words will still remain in lexicographically increasing order only. Okay, but the problem remains in those cases where if we have some as increasing order but we have ABB CD, suppose this was the case. So now this word is in increasing order, but for the further columns we need to satisfy the condition for these two rows as well, because in these two rows the words are the same only. So we cannot put like a CBA like this, because this will disrupt the sorted one. So we need to satisfy the condition for the equal characters to propagate forward. Okay, so this is what we need to make sure. So what if like we try to maintain this lexicographically sorted order step by step. So what if like we try to greedily construct the string and see like at whenever like if we have constructed this string so far, and whenever if the next column is having values in the form of like z and y, so obviously we'll means delete this particular column, because this is not going to help us. Okay, so hence we'll not keep it. But suppose it had the values in the form of yz, so the other values doesn't matter, right? So we can simply keep this column and update our so far constructed result with the values of this column and this column, right? So maybe we can greedily try to construct the vector of strings, and at each step we try to add the values of the current column and then see like whether it is still lexicographically sorted or not. And if it is still lexicographically sorted, then we'll keep this particular column, and if it is not, then we simply remove the like additions that we have done for this particular column. Okay, so this is the approach that we can think of. So what we'll do like suppose we want a vector of strings. So initially we have a vector of strings. Initially we have like we are making this. So suppose this is a prefix that we have made, and initially all the strings are empty initially. Okay, now what we'll do, we'll iterate through each column from 0 to m minus 1. Now in the prefix this vector that we have for each j from 0 to n minus 1, we'll add what? We'll add strs of j comma I to prefix of j. Okay, so to prefix of j we'll add this current character. Now we'll have this modified prefix vector of string. Okay, so we'll see like whether this condition is satisfied, like prefix of j is greater than prefix of j minus 1 for all j from 1 to n minus 1. This condition should be satisfied, right? So if this condition is satisfied, then the means picking this particular column as part of our prefix result was a good decision. So hence we will keep that as a part of our result. But if this condition is violated at any step, that means at any step it becomes that prefix of j is less than prefix of j minus 1. That means the words present at prefix of j is not the same as prefix of j minus 1. In that case, what you'll know that it is not feasible to pick this particular ith column that we have, means this addition is not good. Since what we'll do, we'll remove, means for each of these words for prefix of j from 0 to n minus 1, we'll remove the last character. We will remove it. Okay, and simply increase our deletions count. So we'll increase the deletions count by 1. So this is what we'll do. We'll first try to add it, then see whether that condition is violated or not. If the condition is violated, then we'll simply increase the deletion count and remove the characters. And if it is not violated, then we'll simply keep the characters. So let's see the code for this approach and see like how we are going to implement it. It is simple. Like what we'll do, we'll have the n and m as the means m is the length of each string and n is the number of strings. Now the current prefix that we have made is initially empty. This vector stores the rows constructed so far using kept columns. And this is the deletion count. Now what we'll do, we'll iterate through each column. And at each step what we'll do, the current rows of I from 0 to n minus 1, we'll add this current character which is present at this column. So we'll add str of I comma column in the current row. Now we need to check whether the current words stored in this current rows is in lexicographically sorted order or not. So we'll see like if this condition is is valid is true initially, and we see like whether this condition is violated or not. That means whether this condition like currents of I is the character present at ith row and I plus 1th row. So whether the character word present at ith row is greater than word present at I plus 1 or not. And if it does, then that means we have violated the is valid condition. So we will simply mark is valid as false and break. Now after we had checked if this is valid is like false, that means we cannot keep this particular column as part of our current string. So hence we will increase the deletion count, and what we'll do, we'll remove the contribution of this column characters from our current rows. So we'll for each current of rows of I, we'll simply pop the last character. That means we are removing the contribution of this, and in the end we'll simply return this deletion count. So what will be the time complexity of this approach? So we see like this is going till big of m, this is going till big of n. So maybe m into n, again see this is going till big of n, and this comparison that we have, it will be done in big of m. Okay, so hence n into m into m. So the overall complexity would be m square into n, which will be of the order of all values are 100, so this will be of the order of 1e6. So which will get accepted here, and like this will be one of the optimal approaches to solve this point of form. And means the amount of space that we have used is big of n into m. So let's try to submit this code and see like how much time it takes to run. This is the same code that we discussed. We like create this construct prefix, and like at each step we either have the choice of keeping it or not keeping it, and we do it. So yeah, it runs in 4ms, and like which is pretty fine. So the order of like since the constraints were of the order of 100 and 100, so this approach worked fine. But what if these n and m were till 1000? Okay, what about that case? So in that case, this approach would not have worked, right? So for stricter constraints, maybe like let's see whether we can solve it optimally or not. Because currently what we are doing is the extra complexity that we have is due to this. Means we are not able to know whether this condition of greater is satisfied or not. So what if we try to keep some pre-computations which stores like whether the pair means whether the row I and I plus 1 is currently in the strictly sorted manner or not. Okay, so maybe if we simply means keep this as a pre-computation, then we will not need to do this check entirely. Okay, maybe we can skip. So what we can do is we can simply create a vector bool of like check row of size n minus 1 and initialize it with false. So what it means is that the number of columns that we have processed so far, based on them, if we check row of I denotes that row I and row I plus 1 is strictly sorted or not. Okay, so based on the number of columns that we have kept so far, because we'll be iterating through the columns obviously. Now as we move from the columns forward, we see like based on the columns that we have kept so far, we'll maintain this variable check row of I. This will denote like whether the row of I and row of I plus 1 is strictly sorted. That means we have chosen some characters ch1 and ch2 in these two rows, that if this value is true, that means this ch2 was greater than ch1 in some case. Then afterwards it doesn't matter whatever values comes after them, it doesn't matter, because the lexicographically greater condition we have already satisfied for these characters, for these two rows. Okay, so we can simply maintain this character, maintain this vector. Now how it is going to help us? So for example, if we are at a current condition and current row j and the current column I, so if this condition is satisfied, that str of ij is greater than str of I plus 1 comma j. So if this condition is satisfied, then that means maybe we cannot pick the current character, right? Maybe we cannot pick the current character. But what if this check row of I was already true? So instead of making this invalid as false, because is valid as false, we made this is valid as false initially. Instead of that, we simply see, like, if this check row of I is true, that means row I and I plus 1 are already in a strictly increasing order. So hence, even if we pick these two characters, it will not break the sorted condition, right? So hence, while checking for the current column, we can simply check whether this condition is satisfied or not, and hence will the invalid case will only be there when this condition is false and then this thing is agreed. Then only we'll be deleting it. That means the check row of I is equals to false, and we have like str of I j is greater than str of str of I plus 1 j. Okay, so if this condition is satisfied, that means we cannot pick the current column. So in that case, we'll be like simply not picking the current column, and if we pick the current column, then we'll be updating this check row of I. If it is false and the current condition is like check row of I plus 1 comma j is greater than check row of I means str of ij, then in that case we'll be marking this check row of I as true if we pick the column. So if this condition is not satisfied, means if we do not encounter this condition at all, then that means it will be good to pick the current column. And if we pick the correct column, then we'll simply update this check row of I. Okay, so in this manner, maybe we'll be able to avoid the inner loop of construction that we are doing at each step, and simply based on this check row of like which will only take a big of n space, we'll be able to do that. So initially we are constructing this big of n into m, which took an extra complexity of big of m, right? But here what we'll do, we'll simply create maintain this variable which stores the information about row I and I plus 1, whether they are strictly increasing sorted so far or not. And based on this information, we'll be able to solve the current problem. So let's try to see this code, and then the approach will become much clearer. So we'll simply create this check row of size n minus 1, which will denote for pair I and I plus 1. So we need till n minus 1, n minus 2 and n minus 1. That's why we have made it of the size n minus 1 and initialize it with false initially, because all the strings are empty initially. Okay, now we initialize this deletion count to 0. We iterate through each column. Now we'll check whether we can delete this current column or not. So we initialize it with false and see like if this condition is satisfied, that check row of I is false, and we encounter that str of I comma call is greater. That means this character ch1 is greater than ch2, and this for row I and I plus 1, this was check row of I is false. That means they are not in a strictly increasing order. So we cannot keep them this column, right? So you simply delete current column, we mark as true and simply break. Now if this becomes true, that means we'll increase the deletion count, else we'll be keeping the particular column. Okay, so if we'll be keeping the particular column, then we'll need to if the check row of I was false, then we need to update it, right? If we have if it was false currently, and we have got two characters ch1 and ch2, such that ch2 is greater than ch1, that means we need to update this check row of I as true. That means we have got these two adjacent rows as strictly increasing. Okay, so hence we'll mark check row of I as true. So this is under all those cases where we are encountering equal characters, means ch and ch. So if it had already been sorted and strictly increasing, then it doesn't matter because it will already be true. And if it had not been, means if it is false, then it will still remain false. Okay, it will still remain false based on the other conditions, means condition for other rows. We not need to specifically check whether we have if we have two equal characters here. Okay, so in this manner we will be able to solve it, and in the end we'll simply return this deletion count. So the time complexity of this approach will be this is taking of the order of m, and this is of the order of n, and all the checks inside are of the constant time. So we have avoided this big of m extra thing that we are doing by checking for entire rows, because currently we are simply checking for a single character only. Okay, we initially were checking for the entire word, and that took an extra complexity of big of m. So again, this is also big of n, so and the overall complexity in this case will be n into m, and the space that we have used is big of n. So this will be of the order of 1e4, and this is much faster than the previous approach. And it will also work if there's n and m are of the order of 1e3. So let's try to submit this code here and see like what is the approach. So this is the same code that we discussed. The previous code n square m ran in 4ms. Let's try to submit this and see how much time it takes to run. And as you can see, like it runs in 0ms, which is pretty fast because of the order of 1e4. So these were the proper discussion from the brute force to the better optimized to the most optimized solution. So I hope you were able to follow along, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.